In this video, we're going to revisit the Hogwarts example as a way to look at normalization. So the first thing we want to look at is all of the different attributes in the table. Here we have student ID, student first name, student last name, student house, course number, course name, grade, professor ID, professor first name, and professor last name. The first thing we want to pay attention to is this nested behavior. You can see that we have Harry Potter and Harry Potter's information repeated several times, associated with different course, grade, and professor information. This is going to allow us to create our zero normal form. Since student is on the far left, let's use student as the name of our first relation. We have student with a student ID, student first name, student last name, student house, course number, course name, grade, professor ID, professor first name, and professor last name. Now the only thing we have to do here is put this course to professor information in parentheses. This will represent our nesting. So this is nested and is related to the same student several times. Because we have this repeating group behavior or this nesting, we are not yet in first normal form. The first thing we need to do is get rid of this. That will put us in first normal form. In order to do this, we're going to break this out of the first relation. So we'll have the following. We'll keep the student relation with the student ID, student first name, student last name, and student house. But then we'll have a separate relation. Let's call it enrollment. We're going to include student ID again in enrollment because we need to know it in order to determine the grade. We're going to include the student ID in the enrollment relation as well because it is related to it. In other words, we need to know which students are taking which courses. So we'll have student ID and the rest of the original attributes of course number, course name, grade, professor ID, professor first name, and professor last name. Now from here, we are in first normal form. We no longer have that nested behavior. However, we're not yet in second normal form because we have partial key dependency. How do we know we have partial key dependency? Well, let's first determine what a good primary key for each relation would be. We can actually do this even if it's not normalized. We can even do this for the zero normal form. In order to uniquely identify every single attribute in this relation, we would have to reference the student ID. Thus, the student ID is the primary key in this relation. In these two relations, the student one's a bit obvious. In order to know a particular house, last name, or first name, we need the student ID. There were some questions on functional dependency, so I want to make sure you understand again how to determine if there is a functional dependency or not. If we look at student house, for example, we have Gryffindor leads to Harry, but we also have Gryffindor leads to Hermione. This tells us that house does not determine the student first name. If we go the other way around, however, with student ID, we can see that if we choose the student ID of 1, we only get Gryffindor. If we choose 2, we also get Gryffindor. But remember, having two x's that determine the same y does not make it not a function. We have to examine every non-key attribute and find a key attribute for it. In order to know the grade, we have to know the student ID. So student ID is going to be included. In order to know the professor first name and professor last name, we also need the professor ID. The last part's a bit tricky. We need to decide if the combination of student ID and professor ID determines every single other attribute in the table. So the question is there a one-to-many relationship between professor and course, or a many-to-many relationship? We have to look back at the table data to determine this. What we're trying to figure out is whether or not just knowing the professor ID and the student ID could also determine the grade, and whether or not knowing the professor ID gives us the course number, or the other way around. Let's suppose that the course number determines the professor ID. We look down and we have 100 with 4, 240 with 3, 300 with 5, 400 with 2. If we look more closely though, we also have a case of 400 with 7. What this tells us is that we don't have course number determining professor ID. If we go the other way around with the professor ID, we see that we have 7 leads us to 400, 2 leads us to 400, that's fine, that's still a function, 4 leads us to 100, and so on. Because each professor only teaches one course, but a course can be taught by many professors in this table, we have a one-to-many relationship. This also tells us that if we know the professor ID, we actually know the course number, and the grade. So the combination of just the student ID and the professor ID will give us the rest of the non-key attributes in the table. So our composite primary key is student ID and professor ID. From here, however, we are not in second normal form because we do have partial key dependency. Our partial key dependency is easily seen from here. The primary key of the relation is the combination of student ID and professor ID, but all that's needed to determine the professor first and last name is the professor ID. We don't need the student ID. Let's get rid of this partial key dependency to put us in second normal form. I'm again going to copy the data down. What we want to do is tease out the non-key attributes and the primary key that's causing that partial key dependency. What we're going to do is create a new relation called professor that includes all of the attributes that are only determined by the professor ID. So we have professor ID, professor first name, professor last name. We also said that professor ID determines course number, so we'll include course number and course name as well. And we'll remove these attributes from the previous relation, but keeping student ID and professor ID. We are also going to keep grade because in order to know the grade for a particular student with a particular professor, we need both the SID and the PID. A higher normal form, we have to pick out primary key once again. The first two relations will stay the same, but for our last relation, all we need to know is the professor ID to uniquely identify everything else in the relation. Again, remember, because if we know the professor ID, we know the course number. We're now in second normal form. Are we in third normal form? Do we have any transitive dependencies? We do have the relationship that if we know the course number, we also know the course name, and we have professor ID determines course number, as well as course name. So we do have a transitive dependency here. In order to remove this and get into third normal form, I'm going to copy this down again. And what we'll do is we will take the course number and course name out into its own relation called course, and we'll leave the course number as a foreign key in the professor relation. Course will have course number as its primary key. That puts us into third normal form, and we are then finished. Let's take a look at how to use the normalization tool to get to the different normal forms. You can find this link on Blackboard. First, we're going to enter the attributes that we have. We have student ID, student first name, student last name, student house, grade, course number, course name, professor ID, professor first name, and professor last name. From here, we can tell it the functional dependencies. Let's start with the easy ones first. We know that student ID determines student first name, student ID determines student last name, student ID determines student house. We also know that the professor ID determines the professor first name, the professor ID determines the professor last name, and the course number determines the course name. If you take a look at the current functional dependencies that we have, these don't account for any of the relationships between the entities. We just have the separate student, professor, and course entities. The last functional dependencies we have are those that determine these relationships. We talked about the relationship between professor and course, and student and professor. In order to get the grade, we need both the student ID and the professor ID. And finally, we also said that if we know the professor ID, we also have the course number. Once we're satisfied that we have the functional dependencies, we can choose normalize to 3NF. Either method is fine. Here you can see the resultant relations that we came up with. We have one for student with student ID, house, first and last name. We have one for professor with professor last name and first name, as well as a course number as a foreign key, a course relation with course number and course name, and an enrollment relation with professor and student ID that leads to grade. I encourage you to turn on the Show Steps feature and read through how the functional dependencies end up generating the different normalized relations. You can use this as a resource for your project as well. You can use this as a resource for your project as well.